This building is the headquarters of the Royal Institute of British Architects. But 200 years ago, it was a private house. And one of the greatest experimental scientists of his time, the man who tamed electricity, born near the Elephant and Castle, came to live right here in his early teens. His name was Michael Faraday.
Faraday was one of 10 children. He spent the majority of his life working at the Royal Institution in London's West End.
Michael Faraday was not only a brilliant experimental scientist, he was also a brilliant demonstrator. In this very lecture theatre in the Royal Institution, he used to give the most wonderful public lectures. People would come in off the street and listen to him because he was really brilliant at explaining things. And one of the reasons that he's a real hero of mine is that he saw science in the most ordinary, everyday objects, like candles. Now, these are perfectly ordinary candles. There's nothing special about them at all. I'm going to put this one out and relight it. And do you notice I can light it way above the wick and the flame jumps back? Because what's coming off the wick is not smoke, but wax vapour. And it'll jump a couple of inches through the air if you're careful. You have to make sure there isn't too much draft about. And what's happening is that the wick is actually not just a piece of string, but an elegant engine for getting the wax into the vapour phase, into the gas phase, if you like. Here's the bottom end of a candle, and if I try and set fire to this, just need a flame, there we are, you'll see that the wax doesn't burn. Solid wax simply won't burn, and I'm melting it in the heat from my match flame, but the liquid won't burn either. It's just dripping away. And in order to get it to burn, you have to turn the wax into vapour. That's like gas. And so that's exactly what the wick is doing. Here we've got solid wax, and round the top here there's a lovely little rim forming a cup. And in the middle of that cup there's liquid, there you are, liquid wax, and the wax is soaking up the wick by capillary action, and off the top where it's hot, it's coming off as vapour, and that's what's burning, and that's why I can light it again.
And again. Wonderful. Just look at it in slow motion, frame by frame. There's a tiny dot of blue flame, look there, by my sleeve. A 25th of a second later, and that blue flame shot down the vapour to just above the wick. Beautiful, isn't it?
And let me show you one other beautiful demonstration that he described in his lectures. Here is another candle, ordinary candle, my match has gone out, with a piece of glass tube stuck into the bottom of the flame. Piece of glass tube like this, but it's gone black because there's so much soot about. And with luck, I should be able to light it. There, I've got 2 flames from a single candle.
And the lab where Faraday first tamed electricity is now preserved at the Royal Institution.
And this is it. This is Michael Faraday's own lab, where he did all his greatest work and where he conquered electricity. Now, people had been working with electricity for generations, but he was the person who tamed it and made it work for him. And if you look here, this is his lab notebook. He called it his Diary of Experiments, the first volume. And down at the bottom left corner of this page, there's a tiny diagram, which is the first ever diagram of an electric motor. And thanks to Faraday and his electric motor, we now have starter motors, hair dryers, you name it. Thousands of different electric motors. He was the man who tamed electricity.
Faraday's science wasn't limited to his lab. In 1848, spiritualism was beginning to take off. Table tipping was one of the most popular manifestations. 4 adults placed their hands on a table, and after a little time, the table seemed to tilt of its own accord. Faraday publicly showed how table tipping had nothing to do with spirits of the dead, but could be simply explained by science.
Now, one of the elegant experiments that Michael Faraday dreamed up was this. I've taped here 2 bits of wood onto the table, and you can see the bottom one is fixed to the table, and then there's a row of pencils, and the top one is loose, so that it will move very easily from side to side. Forwards and backwards it won't really move at all, so it'll just be like pushing the table. So what I'm going to ask you to do is to put your fingers on this, and all of the rest of you just put your hands on the table as before. And exactly the same thing, just rest your fingers, please don't press. But before you start, I'm going to blindfold you, Claire, if that's all right,
Okay.
so you can't see what's going on. Can you see?
No.
Can you breathe?
Yes.
Good, I'm very glad about that. How's that?
That's fine.
Okay, now just think about tipping that table, but don't push it. Now you see, if Claire pushes in any direction, you'll see the pointer moving. And if she keeps her fingers absolutely still, it won't move at all. Okay, now can you just stop for a second and take your hands off? When you had the blindfold on, it was moving all over the place. It was actually absolutely heaving backwards and forwards. Because the trouble is that when your hands get tired, you don't know what's happening to them. You're trembling a little bit, all 8 hands, and the result is the tiny unconscious muscular movements